friends, my name is Amita, and in this video I'm going to discuss about another important topic of in basic electrical and electronics engineering, that is the current division rule. My dear friends, current division rule, as the name indicates, it is used to calculate the magnitude of a current in a parallel connected elements. We know that in parallel combination always currents divide, and in what proportion it will divide in the parallel connected elements, we can determine that magnitude with the help of current division rule. So now directly I am sharing my screen where I will brief you the current division rule. So let us start with the current division rule. As the name indicates, this rule helps to determine the magnitude of current in parallel connected branches. Okay, for an example, suppose there are two resistances, values are R1 and R2 are connected in parallel and fed by a voltage source of V. Okay, there is a total current I, and the current in the individual parallel connected branches are I1 and I2. So R1 and R2 are the resistances which are connected in parallel. I1 and I2 currents flowing through resistances R1 and R2, R1 and R2. V is the DC input voltage and I is the total current flowing in the circuit. Okay. Now let us again draw the circuit so that we can understand the current division rule and can determine the expression of a individual current flowing through the parallel branches. So plus minus V, this is I, this is I1, this is I2. Due to the parallel combination property, we know that the voltage across the parallel connected elements is always same. As in the circuit, R1 and R2 are connected in parallel and this parallel combination is fed by a voltage source of V. So the voltage across R1 resistance will be equal to V and the voltage across R2 resistance will also be V. Okay? As we know that the current in any branch of the circuit is equal to the voltage across that branch divided by the resistance. So the current through resistance R1 will be equal to voltage across R1. So what is the voltage across R1? That is V. And what is the resistance? That is R1. And this I can write it equal to I1 because the current flowing through resistance R1 is I1. Similarly, so we can write I1 is equal to V by R1. Now, similarly, the current through resistance R2, that is I2, and that is equal to V by R2. Okay, now we know that the resistances are connected in parallel. So the equivalent resistance will be what will be the, suppose 1 by R equivalent, that is equal to 1 by R1 plus 1 by R2. This if I solve it, R1 R2, R1 plus R2. So from here R equivalent will be equal to R1 R2 upon R1 plus R2. Okay. Now if I draw the circuit again, we know that this is R1, this is R2, this is V, this is I, this is I1 and this is I2. So if I want to calculate the total current I, that will will be equal to total voltage V divided by R equivalent. So V by, what is R equivalent? R1 R2 upon R1 plus R2. So what is the value of I? That is V R1 plus R2 upon R1 R2. Okay, so now as we know that I1 is equal to V by R1 and I2 is equal to V by R2. So put the value of V in the expression of I1 and I2. I1 and I2. Now which V? I will calculate the V from this equation. Suppose this is equation number 3. Suppose this is equation number 1. Okay, and this is equation number 2. So what we are doing basically, we are putting the value of V from equation number 3 to equation number 1 and 2. So what is equation from equation number 3? What is the equation? V R1 plus R2 upon R1 into R2. So from here V is equal to I into R1 R2 upon R1 plus R2. Okay. So put this V in equation number 1 and 2. So from equation number 1, I1 is equal to V by R1. Put the value of V, that is I R1 R2 upon R1 plus R2 divide by R1. So R1 से R1 cancel. What I am going to get? I R2 upon R1 plus R2. This is suppose equation number 4. Now similarly, put the value of V in equation number 2. So what is I2? I2 is equal to V by R2. That is your equation number 2. V की value क्या है? I R1 R2 upon R1 plus R2 multiplied by R2. So this cancelled. I R1 upon R1 plus R2. And this is equation number 5. So finally what I am getting? I1 is equal to I into R1 upon, R2 into R1 plus R2. And what is I2? I2 is equal to I into R1 upon R1 plus R2. So these two formulas are called as an current division formula. Why it is called current division formula? Because these formulas relates the current in a parallel branch with a total current I. Okay. Last I can say that current division formulas are nothing but with the help of these formulas we are able to determine the magnitude of a current in a parallel connected branches if we are aware about a total current or a applied voltage to the parallel connected circuit. So I am stop sharing my screen. I hope whatever information I have shared in this video that will be useful for you. If you want to learn more about the basic electrical and electronics engineering related topics, then keep watching my video. Thank you.